High-level and long-lived radioactive wastes and spent nuclear fuel are generated mostly in Paks nuclear power plant. Our movie is to demonstrate the conception plan about their final disposal. The first task of this is the site investigation for development of an underground research laboratory. In the research laboratory, technical and scientific experts work on research and technological tasks, demonstrating the suitability and safety of the applicable technologies with full-scale experiments. Among others, they investigate the features of the hydrogeological and geochemical environment, the mechanical behavior of the host rock, the practical solutions of the transportation and emplacement of waste packages. Some of the investigations could take 1.5 decades, such as the study of changes caused by heat load. The research laboratory also gives an opportunity to train the staff of the repository. If the results of the more decades-long investigations convincingly prove the suitability of the host rock, the disposal areas will be developed with mining methods. During the operation and the commissioning of the nuclear power plant, about 300 cubic meters, but during different research and educational activities, about 200 cubic meters high-level waste are generated. After cutting into proper pieces, the high-level radioactive wastes, such as certain parts of the reactor vessel, will be put into massive concrete containers. During the operation of the nuclear power plant, more than 11,000 spent fuel assemblies are generated. The radiation and heat generation of the spent fuel assembly significantly decreased during the 50 years long interim storage, so the transportation can be solved easier. The assemblies are put into a corrosion-resistant copper container, including a robust steel basket. The final hermetical closure of the container is made by welding. The seam is controlled carefully. After this, 3 copper containers, each of them including 12 assemblies, are put into a transport cask. The waste packages are transported on public roads with keeping strict safety and security rules. The opening of the transportation cask is foreseen in the reception building of the surface site of the final repository. The copper container is moved by remote control to the lift, which takes it to the disposal area located at 500 meters depth. For receiving the waste packages, 7-meter deep boreholes with almost 2-meter diameter are formed in the chambers. Into the boreholes, pre-compacted and manufactured bentonite rings are installed. Bentonite is an excellent water-isolating material which swells under wet conditions and prevents the water from getting to the copper container. The full repository is backfilled with the mixture of bentonite and crushed host rock. The applied engineered barriers and the geological environment ensure the isolation of the radioactive isotopes from the living environment for many hundreds of thousands of years. Besides the technical details of the disposal concept shown may vary, the experts have also been studying other alternative solutions.